This is Algebra 3.2, or Algebra 1, Lesson 3.2, on solving equations using multiplication division. And this picture is of a recycling plant that recycles paper. And paper is the most recycled product in the United States. And later in this lesson, we're going to use an equation to solve based on the weight of paper that's bundled at a recycling plant. So inverse operations are operations that help you isolate the variable like x on one side of the equation. And so multiplication and division are inverse operations. From multiplication, the inverse operation is division, and the inverse operation of division is multiplication. You can use multiplication to undo division, and you can use division to undo multiplication. And my cat is right here on top of this iPad, so you're going to hear it purr. Now, we've already talked a little bit about this in the last lesson, but you use inverse operations to solve an equation in several steps. You perform the same operation on both sides of the equal sign to keep the equation balanced. So the aim is to get the unknown or the variable like x or y or a on one side and the number on the other side. And so an example, 4x plus 5 equals 29. We subtract 5 from both sides, and we end up with 4x equals 24. Now we divide both sides by 4, and we get x equals 6. And so if you notice, this right here was a multiplication, and so the inverse operation was to divide, and of course we have to do it on both sides, and we end up with x equals 6. And then you can plug that back in and make sure that you have the right solution. So here's another example. It's a little fuzzy, but I think you can get it. So in arithmetic, if 3 times 4 equals 12, we can use inverse operations to say 12 divided by 4 equals 3, and 12 divided by 3 equals 4. That's something that you already know how to do. In algebra, if you have AB, which means A times B equals 12, we can use inverse operations to write 12 over B equals A, and 12 over A equals B, or A equals 12 over B, and B equals 12 over A. So we took the inverse. So in this example, we're using inverse operations again. We have x over 7 equals 3. We rewrite that as x equals 3 times 7, and we get x is 21. So the multiplication was the inverse. Over here we had 3x minus 4 equals 14. This is multiplication here. So we have 3x equals 14 plus 4. 3x equals 18. X equals 18 divided by 3, and x equals 6. And then we can check that. So over here, basically you're using on this side the inverse. It's not showing that we simply rewrote it, but it's not showing, for example, here that we got rid of the 3 by dividing the x, because it just sort of ensues that when you divide by x, you're just going to end up with x, and then you have 18 divided by 3 over there. So let's look how we solve an equation by dividing on both sides. So our equation is negative 4x equals 1. Step 1 is to write out, and you would do this on your homework paper. You have negative 4x equals 1. Step 2 would be to divide both sides by negative 4, and we do that because it's the inverse of the multiplication here, 4x. So we put the 4x over negative 4, 1 over negative 4. That undoes the multiplication. That also then, so it cancels out that, and we're left with x equals negative 1/4, and that is as simplified as it can get. And then we can go back in and put that in our original equation, multiply it out, instead of the x there, and we should get 1. So in this case, now we want to try to multiply both sides. That's an example here. The problem says solve x over 5 equals negative 30. This division division is the operation, so the inverse is going to be to multiply to isolate the variable x. So the first thing we need to do is to rewrite the equation. We have x over 5 equals negative 30. The second step then is to multiply both sides by 5, because it was a division here, to undo the division. So we have 5, now it's 5 times x over 5 equals 5 times negative 3. Essentially that crosses that out, and you're left with x equals negative 150, and that's as far as we can go. This is what these steps should be what's on your homework. So let's look at this. We have 60 equals 5x. The way I wrote it, that I've already basically rewrite it, so it's fine in this case because I wrote it like that. Now we have to divide each side by 5. So it's going to be 60 divided by 5 equals 5x divided by 5. It's going to cancel out that, and that will leave us, we'll simplify, and we are left with 12 equals x. You can check that by putting 60 equals 5 times 12. And while I'm thinking about it, whenever you're writing algebra, don't do this sort of thing when you're writing it down, because this is too confusing for someone. Does that mean times? Is that 5x? So when you're writing down multiplication, you need to do it like that, okay? Or if it's a variable, just like that. Let me erase that because that was just a side note. The same thing would apply if you were doing division. We don't write down 60 divided by 5 using this mark. We're going to write it like this in a fraction form. So watch that on your homework. Let me erase this and that. Okay. So, and it does work out. We end up with 60 equals 60. So now we have r over 3 equals 11. See if you can figure that one out. Put it on pause and see if you can figure it out real quick. Hopefully you did. So the first step that we need to do here is write the original equation. Whoa. And that would be that. The second step, in this case we have division, so the opposite that we want to do is multiply, as the inverse. We're going to multiply both sides by 3. And these will cancel each other out, and then we end up with r equals, sorry about that, 33. When we simplify, and you can check, you can plug that back in. 33 for r equals 11, or sorry, that was 3, and that does equal 33 divided by 3 does equal 11. So let's try n divided by 4 equals negative 2. Take a minute, see if you can figure this out on your own. So the first thing we do is we write the original equation, which was this one, on our answer sheet. It's n over 4 equals negative 2. It's division, so to undo that we need to multiply. We'll do that by multiplying 4. So these will cancel each other out. Now we need to simplify, and we have n equals negative 8. You can plug that back in up there, and you can see, just eyeballing it, that in fact the answer will work out to be negative 2. So we have another equation. Let's say negative 3x equals negative 9. So on our paper we write the original equation down. Step 2, we have multiplication here, so we're going to divide on both sides, and we would end up with negative 3x over 3 equals negative 9 divided by 3. These will cancel each other out. And be careful, because I made the mistake here and didn't write the negative signs, and that will mess you up. So make sure that you don't forget when you're dividing, that if it's a negative you have to divide by a negative here. And 3 is going to be to simplify, and that would give us x equals 3, because we had 2 negatives there. Okay, so an x will equal 3. You can already see that when you plug that back in up there, that it will work out. Okay, now we're going to talk about reciprocals. And so to solve an equation with a fractional coefficient, such as 10 equals negative 2 over 3m, multiply both sides by the reciprocal of the fraction. So what does that actually mean? So let's look at the equation that I said on the previous screen. The fractional coefficient is this right there, negative 2 over 3. The reciprocal of that, of negative, need to be careful because where we put the negative signs, is negative 3 over 2. So this is the reciprocal, of this. So we follow the same procedure. We rewrite the original equation. I'm having problems with my negative sign, so I'm going to leave it off for a moment. Okay. And now I want to multiply both sides by the reciprocal. So that's my step 2. So I'm going to do okay, so I have the reciprocal here. We multiply both sides, and now we simply solve. So I'm kind of out of space here, but so I'm just going to do, so right here, I'm just going to do this. So I can multiply this out, and I would get negative, let's see, 30 over 2 equals, and these all cross each other out. This works its way down. This answer is going to be negative 15 equals m. So hopefully that wasn't too confusing how I did that. So we'll try a few examples and see if it makes sense. So here's an equation. Just to save space, I'm going to use it how I've written it here as my woe, written right out the equation. So we have 6 equals 3 over 4 times x. And so the first thing we want to do is multiply by the reciprocal, both sides. So the reciprocal will be for 3 times 6 equals 4 over 3 times 3, 4x. We can see that these cross each other out, and this side will work its way out to equal x. And just to make sure that you saw how we get the 8 there, it's going to be, do it backwards, that's 24 over 3, and that is going to equal 8. Okay. Always test to make sure that when you plug it back in, it works out to be the same thing. So that would be 18. And we would put the 8 up here, and then you could multiply that out. And this would end up being 6 equals 24 over 4, which equals 6, and so it is equal. 6 equals 6. Okay, so here's another one. We have 12 equals negative 4/5 times y. We want to multiply by each side by the reciprocal. So we would end up with, so I've written out that with the reciprocal here of the 4/5. When we do that, we can see that we can eliminate on this side. And we have 2 negatives, so we're going to end up with just a y there. No negative sign. And over here, we can multiply that out. We're going to get 60 over 4, which equals 15. So the answer will be negative, because we had a negative there, negative 15 equals y. You can plug in the negative 15 here, multiply that out, and see if your answer works, and it will. So that one ends up with 12 equals 12, because we're going to have a negative, 2 negatives there, so we'll end up with a positive 12 there. So here we're going to use, we're going to multiply by the reciprocal. So we will have 5 over 3 times 3 over 5x equals 5, 3 times 24. We can eliminate, and we get down to x equals, and we're going to have x equals 40 when you multiply that out. And just to make sure, you're multiplying 5 times 24 and 3 times 1, because 24 would be over the 1, and of course that, by the time you work that out, it does equal 40. You can go back in and plug in your answer. So x would be 40 equals 24, and you can check to see, and it does in fact 24 equals 24. So we have another equation which we have written down our original equation. It's negative 6 equals 2 over 7 times m. You can multiply by the reciprocal. I can cross this out, so that's going to equal m. We can multiply this out. We will end up with 42 over 2. And 42 divided by 2 is going to be negative 21 equals m. And then you can replace this m up here with negative 21. And just put that over 1 and multiply. And you should work out to be the same thing. Negative 6 should equal negative 6. Okay, now I want to talk to you about the properties of equality. And really, just for this lesson, we're worried, I want to talk about this group, but I wanted to show you that there's 8 of them altogether. The first one is the addition property, is if A equals B, then A plus C equals B plus C. So A equals B, if I add C and to both sides, it's going to equal. The subtraction property is if A equals B, then A minus C will equal B minus C. Multiplication property is if A equals B, then A times C equals B times C. And the division property is if A equals B and C does not equal 0, then A over C equals B over C. And so why is this important? Because the way that we've been talking about transforming an equation into an equivalent equation, they're based on these rules, the properties of equality. So that's what all of this is based on. Movie frames. You have a single picture on a roll of a movie film, and it's called a frame. And the usual rate for taking and projecting a professional movie is 24 frames per second. That's going to be a lot of frames by the time you're through with an hour-and-a-half movie, isn't it? So, and an hour-and-a-half movie is going to be 90, if I can write 90 minutes. Oh, here, it's kind of messy looking. Is 90 minutes long. Now, let's say that the equation that you've been asked to figure out is what is the total number of frames in this 90 minute movie. So to figure out the solution, we're going to have x equal the total number of frames in this movie. Okay. And to find the total number of seconds in a movie, we would multiply 90 by 60. That's 90 minutes by 60 seconds. Because each minute is 60 seconds. And so, knowing that, we can say, remember, one of the reasons we have to figure out work with seconds, because the formula that was given to us is that it's 24 frames per second. So that's why we have to convert the minutes to seconds. So my initial, I got number of total frames in the movie is going to be up here. This is in the movie. I'm having problems with my stylus, so it's not working too well. And on the lower half here, I have total number of seconds in the movie is going to equal the frames per second. So let's go to the next. So we figured out 90 times 60. We're at 5,400 here. We don't know the number of frames in the movie. That's what X is, right here. And we do know that it equals 24 because there's 24 frames per second. So here's our original thing. Sorry, that's my... So the next thing, sorry about that. Now we need to, we have a division, so we're going to multiply with the reciprocal. If I can get my pen to work. Okay, so we will multiply 5,400 equals 5,400 times 24. We can cross out that. We are left with X equals 129,600, and my silly cat is back on the desk. And so what we can say then at the end is the 90-minute movie had a total of 129,600 frames. Now, motion picture studios, they tried to go back and save older films, like like black and white ones, Charlie Chaplin movies, from decay, and they do that by restoring the film literally frame by frame. So you can imagine how many frames they're going to have to go through to restore a film. So let's say that a worker can restore 8 frames per hour. And what he's doing is restoring. So we're going to restore 8 frames per hour. And let's let y equal the number of hours of work needed to restore all the frames in a 90-minute movie. And so if this was a problem that you encountered, you'd have to be able to figure out how to set it up. So I'm going to go to the next screen. So I set up our verbal model here. We have the number of frames restored per hour, the number of hours of work that it will take, and the total number of frames in the movie. And we already know that our 90-minute movie, because we worked it out before, has 129,600 frames in it, because that's what we worked out before. So now all we have to do, we know that I told you it takes 8. You can do 8 frames per hour. And now we need to figure out the number of hours of work, how long it's going to take to do it, and we don't know that yet. And we simply then set up, so this is our first problem, is 8 times y equals 129,600. Now, you can use, because we have multiplication here, and I should have written this, because I told you earlier, like this. without the dot or the x for multiplication. We have 8y, which means that we can now divide both sides. So let me go to the next screen. So let me rewrite it. We have 8y equals 129,600. We're going to divide both sides by 8. And y then, when you work it all the way out, is going to be 16,200 hours. Okay, so your assignment, part 1, because this is in 2 parts today. Part 1 is pages 141 to 143 in your book, exercises 19 through 21, 25 through 27, 33 through 34, 33, 34, 40 through 42, 49, 50, 54 through 59, 63 through 65, 73 through 75. But the good news, or bad news, is we're also going to do lesson 3.3. So listen to, you can stop and do your assignments for 3.2 and then come back to the video, or you can listen to it all the way through and go back and do both. I probably would do 3.2 and then come back, but you can't take your laptop or your Chromebook home. So if you need to watch it both ways so that you can know what it is, that's fine. Make sure on your piece of paper, your homework paper, you have written down what your assignment is. Okay, so I'm going to pause here for a second, let you write down what you need to do and decide what you're going to do, and then you will have to go listen to 3.3 on another video, because I'm going to do it separately.